I thought I'd run through these questions. This is mock test 3 that I sent out to you. It says a particle is moving along the x-axis so that its velocity at time t is given by, it gives you that function up there. At time t equals 0, the initial velocity of the particle is x equals 7. Hey, this came from a non-calculator question, of course. Now, sorry, this came from a calculator question, and now they are all calculator questions. But kind of keep that in mind, and just make sure you have your calculator out as you go through these, so you know how and when to use them. Okay, so first it says, like, it gives you that velocity. It tells you at time equals 0, the initial position is at x equals 7. It first wants us to find the acceleration of the particle at time equals 5.1. So right, we have the velocity. So to find the acceleration, we're going to take the derivative. Because it's a calculator problem, and all of yours will be, I don't need to show any work. I'm just going to go like this. V prime of t is equal to a of t. Okay. So now I'm going to take it and go, what is, v prime to 5.1? Or in other words, what is the acceleration of, what is the acceleration at 5.1? Okay, we're going to grab the calculator and put that in there. Remember, you go to the math menu, you go down to n derive and d dx. Here, I'll put this up on the screen here so that you can see what I'm doing. All right, so there's my calculator, and I'm just going to punch in there, or I'm going to go to math and go down to n derive d dx, put our function in there. So let me just scroll back up a little bit here so I can see our function. So we have x to the 6th minus 13 x to the 4th plus 12. I'm going to put that in parentheses over divided by 10t to the 3rd, 10x to the 3rd. Oops, I need my parentheses over there, sorry. 10x to the 3rd plus 3. In parentheses. Okay, so I got my function in there. Then we want to evaluate it at 5.1. So we're going to put when x equals 5.1. Hit enter, it thinks for a second. There is our answer. Okay, it comes out to be, if we make sure you go 3 decimal places, but it comes out to be 6.491. That's what that works out to be. Okay, part B says find all the intervals in t when the speed of the particle is equal to 1. So again, you're going to come back up here. We know that the speed is the absolute value of the velocity. So, and you need to show your work. So we're going to say we want to find out when the absolute value of v of t is equal to 1. So that means I'm going to use this, the absolute value of t to the 6th minus 13t to the 4th plus 12 over 10t to the 3rd plus 3. We want to find out when that's equal to 1. And again, this would be impossible to solve without a calculator, but we can use a calculator. I'm not going to go through and do this part, but we would just minus the 1 over and then put that equation, graph that equation, y equals that. In our calculator, we're trying to find where it crosses between 0 and 2. And so you only have to look on that interval from 0 to 2 and find out where it crosses, and that would be your solution right there. The answer on part B there comes out to be, it was like 0.772 and 1.401 as you put that in the calculator. Hey, by the way, points, that 1A was 1 point. That's a pretty basic problem. It's using a calculator to find the acceleration. B was worth 2 points. You get 1 point just for including that the absolute value of v of t has to equal 1. Okay, that earns you 1 point. The second point is actually putting it in your calculator and using it to to solve that. Hey, C, just be careful on the scoring guide. Part C had another part to it. It wanted you to find the position at a certain time, which is not something that you're required to do since with the stuff that they dropped. So we're only doing the second part of part C, but if you look at the scoring guide, you'll see some stuff that isn't necessarily included there. Okay, so the only part we're doing is a particle moving toward the origin or away from the origin at t equals 4. So remember, if you got to look at the velocity. If the velocity is positive, it's moving away. If the velocity is negative, then it's moving towards it. So all you really had to do is say, what is v of, and you're just going to plug in 4. And now your question you're asking yourself is it positive or negative? And I think when you plug it in there, you get like it's a positive, like 1 point something. Since it's positive, then you just need an explanation. You want to justify your answer. So I think it was a positive 1.2 something. And you're just going to say velocity is positive. So it's moving away. It doesn't want to write down there anymore. That's all you have to include on that part right there. Okay, part D, the last part there. Oh, looks like my computer is freezing up here. Let me hurry and restart this, and then we'll do part D. So I got that restarted, and part D is actually something that's not covered on the test. So that was it for that question. Those are the parts we're going to do. Let's move on to the next one. So this is question number 3. And this came from the 2019 practice test. Actually, sorry, this is actually number 6 from the same test as the last one. We'll do that. Then we'll go on to number 3. This is still from the 2017. So this is a related rates problem. If you look at it, it says for between 0 and 6 seconds, a screensaver on a computer screen shows 2 circles that start as dots and expand outward. Part A says at the instant that the first circle has a radius of 9, the area is increasing at a rate of 3/2 centimeters per second. Find the rate at which the area of the circle is changing at that instant rate. Indicate the unit of measure. So we want to find the rate that the area is changing by when the radius equals 9, and the rate of change of the radius, so that'd be dr dt, equals 3/2. This is a related rates problem, right? So since it gives me the rate of change of the radius, and it wants me to find the rate of change of the area, I need to come up with a formula that ties those two together. So the formula for area, right? Area equals pi r squared. That's our formula, and that ties together the radius and the area. So now this is a related rates problem. So I want to find what is, we know the rate of change of the radius with respect to time. We want to find the rate of change of the area with respect to time. So I'm going to take the derivative with respect to time. So the derivative of A is dA dt equals derivative of pi r squared to be 2 pi r, and don't forget the dr dt. Right, when you're taking it with respect to time, you have to take the derivative of each, you have to include that hook-on factor, the dA dt, the dr dt for each variable. Okay, we got that all set up. Now plug in what we know. So we're trying to find dA dt. I know the radius equals 9, so dA dt, the radius equals 9, so 2 pi times 9, and dr dt is 3/2. Make sure you're careful if the rate's positive or negative. It said the radius, it's increasing, it's getting bigger, so it has to be a positive. So we plug all that in there, to go 2 times 9 times 3/2, I think it ends up being 27 pi. And then make sure you have to include a unit of measure, right? It says right there, and I would write a sentence to end this. I would say, the rate of change of the area is 27 pi, and area is the rate of change of the area. So it was centimeters, so we would say 27 pi square centimeters per second. Right, so it's a rate of change. You have to have, right, square centimeters per second would be the answer there. So you'd write a sentence that gave your answer for that one. Okay, part B says the radius of the first circle is modeled by that function, where Wt is measured in centimeters and t is measured in seconds. At what time t is the radius of the circle increasing at a rate of 3 centimeters per second? Let's take a look at that. Oh, on the scoring on that part A, I want to hope y'all notice, like you got 1 point for finding dA dt, 1 point for finding the answer. You get 1 point for putting the units. So even if you didn't know how to do that, you made up an answer, but you included the correct units, the square centimeters per second, you're going to get a point off that question. So make sure you're trying every problem and you're careful with units and such. Okay, anyway, part B. The radius of the first circle is modeled by that when t is between 0 and 6, where Wt is measured in centimeters, t is measured in seconds. At what time is the radius increasing at a rate of 3 centimeters per second? Okay, so we want to find out when is the radius increasing by a certain amount. That means we want to find the rate of change or the slope or the first derivative. So that's what we're going to start out is by finding the first derivative. So we're going to find w prime to t. So the 12 goes away, minus 12e to the negative 0.05t, but then I have to times by the derivative of the inside, which is a negative 0.05t. So I got to times by negative 0.05. So we do some simplifying there, right? It comes out to be negative 12 times negative 0.05 is a positive 6. 6e to the negative 0.05t. That's what my rate of change is for the radius of that circle. And we want to find out at what time is it increasing at a rate of 3 centimeters. So I'm going to plug 3 in here. By the way, this was a non-calculator problem. Now I know now we can use a calculator, but just so you know. So what time was the rate of change equal to 3? So we plug 3 in for the derivative, try to solve for t there. So I divide by 6. That'd be a half equals e to the negative 0.05t. Take the ln of both sides. Ln of a half equals ln of e, which cancels out negative 0.05t. Divide by negative 0.05. Okay, and that's your answer right there. If you look at the scoring guide, they simplified the ln of a half. They wrote it as being the ln of 1 minus the ln of 2. ln of 1 is 0, so you have a negative ln of 2 over negative 0.05. Okay, that makes it a positive. 0.05 you can change to a fraction if you wanted. It's 1/20th. You times by the reciprocal. Anyway, they did a lot of simplifying there. And sorry, that wasn't supposed to be negative 0.05. It's supposed to be negative 0.05. Sorry, the point's right there. That would be important. Sorry, 0.5. That's 0.5. So that'd be a half right there. So you times it. Anyway, you can simplify it all the way down to be 2 ln of 2. That's fine. I mean, if you want to do that, that's great. You're just fine leaving the answer like that. Okay, that's great also. Okay, so that would be the answer. If you look at the scoring sheet, they gave you 1 for finding w prime of t. They gave you 1 for setting it equal to 3. That was the second point. And they gave you a point for finding the answer. Again, get in the habit of writing a sentence out. So my sentence would be, the radius is increasing at a rate of 3 centimeters per second at ln of a half divided by negative 0.5 seconds. That's what that would come out to be. That's all we did on that one. That was 6 of the 9 points on that question. The third part of the question gets into stuff that we're not covering, like that's not going to be on your test there. Okay, the last question was this one. They give you this function f of x. It's a piecewise function, and they want you to find the average rate of change. Remember, to find out if you have the function, so if we have f of x, we want to find the average rate of change. All I do is find the slope from negative 3 to 4. So I go f of 4 minus f of negative 3 divided by 4 minus negative 3. And again, the nice thing is you don't have to memorize this formula. This is all in our book, right? You just need to make sure you can look it up and know where to find it. So I need to find f of 4. So I'm going to plug 4 in. When I plug 4 in, I'm going to plug it into this function. So I'd get negative 4 plus 3 cosine, and if I plug 4 in for x right there, I get 4 pi over 2, which is 2 pi. So that's f of 4 minus f of negative 3. That one I'm going to plug into this function up here. Negative 3 squared is 9. 9 minus 9 is 0, so that's nice. It works out to be 0. 4 minus negative 3, 4 plus 3 comes out to be 7. So let's see, cosine of 2 pi. You know, again, you can have your unit circle in front of you, but 2 pi is all the way around. We're back to there. And the cosine's equal to 1. So I go, this ends up being 3 times 1. So I get negative 4 plus 3 times 1, which is 3 over 7. Add those together. You know, that's what my answer is going to work out, is to be a negative 1/7. If you wanted to, again, if it's a free response, like you can leave it like that. At least later on, possibly, maybe you'll have to simplify it, but there's no reason to go past there if you don't want to. There's no need to. That's the same answer, and you get full credit for that. If you look at the scoring guide there, for that part A, you just get a point for the answer. It was only worth 1. All right, B says write the equation for the line tangent to the graph at x equals 3. Okay, so we want to find the equation tangent to it at x equals 3. So I need to find the equation of the line, tangent line. We should automatically be doing this. So I need a point and I need the slope. So I'm going to come back up here. We know x equals 3, but I've got to find what the y coordinate is that goes with that. So pick the right function to plug 3 into. That we're going to use this one right here, right? So let's plug 3 into there. So we get what? Negative 3 plus 3 cosine, plug 3, so pi times 3 over 2, so 3 pi over 2. Okay, that's going to give me the y coordinate. We can simplify that a bit. Cosine of 3 pi over 2, right? Think of a unit circle. 3 pi over 2 is right there, right? 1.5 pi. The cosine at that point is equal to 0. So that means that's going to work out to be negative 3. Okay, that's the first part. The second part is we still need to know what the slope is equal to. So let's find out what the slope's equal to. To do that, I need the derivative. If you're taking the derivative of a piecewise function, if I'm trying to plug 3 in, that means I just take the derivative of that part. That's the part that we use when x equals 3. So I would take that and go, f prime, f of x is equal to, let's write down that function, negative x plus 3 cosine of x pi over 2. And that's when x is between, where's our range there? That's when x is between 0 and 4. Okay, so let's go ahead and take the derivative of that. So I'm going to take f prime of x. That'd be negative 1 plus 3. The derivative of cosine x pi over 2 is a negative sine pi over 2 of x pi over 2 times by the derivative of the inside. The derivative of x pi over 2 is just pi over 2. Okay, we can do a little bit of simplifying here, and well, let's actually just plug 3 in. So I'd get, f prime of 3 is equal to negative 1 plus, I'm going to times the 3 and the pi over 2 together, so 3 pi over 2, negative 3 pi over 2, let's change that to a minus. Times by the sine of, we're going to plug 3 in now, so 3 pi over 2. Okay, the sine of 3 pi over 2 is negative 1, so you think after all that, we ought to end up with negative 1. That was negative 1, so that'd actually make that a positive. I had that right. So negative 1 plus 3 pi over 2. That is the slope. So Now I've got all that stuff. Now I just need to plug it into this equation up here. So I'm going to go y minus my y coordinate. So y minus negative 3 would be y plus 3 equals my slope. That's negative 1 plus 3 pi over 2. Make sure you put it in parentheses. Times by x minus 3. That's the equation of my tangent line right there. So I got a little messy with the slope there, right, going through and finding that. Points, let's look at points here really quick. So the way they scored this thing is they gave you 1 for finding f prime of 3 and 1 for finding the equation. That's where your 2 points ended up being. Okay, part C we skipped. Part C was finding the average value, which is one of the things that they took out, so you don't have to worry about that. Part D was a little bit tricky. It said, must there be a value of x at which f of x attains an absolute max or an absolute minimum? So remember, to get an absolute max and absolute minimum, the function has to be continuous over the interval, and it has to be defined at the endpoints. So if you look back up here, these two functions are both continuous. And when we know we plugged in negative 3 and 4, so the endpoints exist. So since this part's continuous, and this part's continuous, and they have endpoints, really all we have to check is the function continuous at 0 when it goes from one function to the other? So what you need to do is plug 0 into both of those to show that it equals the same thing. So you could say if I plug 0 into the square root of 9 minus x squared, that'd be 9 minus 0, be the square root of 9, so it'd be 3. So I plug 0 into here, I get 3 out, and you could show that. If we plug 0 into here, I get 0 plus 3 cosine of 0. Well, the cosine of 0 is 1, so you end up with 3 also. So the two parts of the function at 0 are both equal to 3. So if you want to do the proper formatting, you say the limit as x approaches 0 from the left side is equal to 3. The limit as x approaches the right side is x equals 3. Therefore, the function is continuous. And since it's continuous, it has an absolute max or it has an absolute min. It's not asking you to find them. You just have to say that it is. So the main thing there, right, you have to show that at x equals 0 that it's continuous, where the two piecewise parts of the piecewise function come together. And you have to just justify that if it's a continuous function that has defined endpoints, then there is an absolute max and an absolute minimum. Okay, so that's it for that second mock test. Again, you can see there's parts that are pretty simple. There are parts that are a little bit tougher, but just make sure as you go through here that you're really looking at the different parts. Look at the scoring guide as you go and look at the key as you go, and just make sure they all make sense to you. Practice having your book in front of you so that you're checking formulas, you know where everything's at. Anyway, I'll also post a video for the mock test 4, just going through those questions. Hopefully these are helpful to you.